Hello and welcome. Today we're going to be examining a topic that's really important when it comes to data analysis, and this is cleaning. In particular, today we're going to be talking about how to clean your data. So when you collect your data, you're going to have problems, missing data, people filling out incorrect answers. So for example, if you ask someone a question such as how old are you, and someone enters in 546, potentially missing, meaning 54 or 46 or something of that nature, you know that score's incorrect. Someone's not 546 years. What do you do with that? In addition, we're going to be talking about some situations where you might have a variable coded in a particular way, and you might want to change that, dropping a response and calling it missing, or turning around and combining categories. So for example, we run into a lot of situations where Likert scales, something strongly disagree, neither agree nor disagree, those types of questions where you might just want to categorize it into agree or disagree. So you might want to get rid of the strongly, slightly categories and just kind of combine them. Today we're going to talk about how to do that using two primary functions. One is transform within SPSS, and the other one is the compute function. The compute function allows us to make a variety of scales, things like that, do mathematical calculations with some of our data. So that's generally what's on the kind of plate for today. Keep in mind, once again, we're using SPSS statistical package for the social sciences 23. However, most of this should apply back to previous versions and hopefully future versions. Most of the commands are going to be the same. Menus might move around as a general rule. In addition, I want to make one quick comment. We did go ahead and go into edit, options, and I did cycle over within the options so that the variable list will be displayed by names, not the variable labels. I do highly recommend this just as a general work issue. It makes it easier to find your variables as they will be listed by the name rather than the labels. So let's jump into it. What exactly is cleaning? Cleaning is the idea, once again, of taking your raw data straight from the survey, straight from collection, straight from downloading it from some type of source, and putting it into a form where you can actually do calculations. You can do computations, you can do data analysis, things of that nature. Now, once again, data might not always be in that situation. So for example, let's look at the citizen variable. Once again, we're using the federal sentencing data from 2006. Keep in mind, this is a very small sample, a small chunk, subsample of the federal sentencing data set. So any conclusions or calculations or even theoretical things we do today might not be theoretically sound. I'm just doing them as an example to show you and kind of demonstrate why and how to use some of these functions. So within here we have one variable, citizen, which is the nature of the defendant's citizenship. If we go to values and click on the little blue box, we can examine and see what categories there are within this data. So for options for the defendant's citizenship include United States citizen, resident legal alien, illegal alien, not a U.S. citizen, alien status unknown. Let's say, for argument's sake, we wanted to basically take categories 2, 3, and 4, so resident legal alien, illegal alien, and not a U.S. citizen / alien status unknown. Let's say we just wanted to make it United States citizen versus everyone else. There might be a theoretical reason, we might be curious. In this situation, we're simply doing it as an example. What we want to do is we want to recode this, okay, or transform, so that United States citizen is one value, and all of these others are another value. This is one of the key things. Whenever you make a transformation, you always want to make sure you're recording and kind of on pencil and paper jotting down the transformation or the manipulation that you want to make. So in this case, we want to take 1 and transfer it into a value. Let's keep it at 1. So 1 in our new variable will be United States citizen. For 2, 3, and 4, we basically want to combine all of these values into another value, lump them all together. In this situation, let's just make them a 0, because for other future reasons, we might just want to be able to filter non-alien or any type of the category 2, 3, or 4. We might just want to have the United States citizens stand out for a variety of reasons. So in this situation, let's code all of those into 0. So first off, let's take a look at what this data looks like. So we're going to go to transform, we're going to go to analyze, descriptive statistics, and frequencies. First things first, always make sure you check what the data looks like before you do anything, because we want to get a comparison to make sure we're correct. So I'm going to make sure display frequency tables is checked. I'm going to pull over the citizen variable and I'm just going to run it. Don't need anything else, because all I want is an output of exactly how many individuals are in this data coded as that particular way. So we see here we have United States citizen as about 43,000 individuals, and then 3,000 for resident alien, about 20,000, almost 21,000 for illegal alien, and not a U.S. citizen, alien status unknown, is about 1,200 individuals. We can see we also have about 3,000 individuals who are just missing. We don't have any type of information on them. So what we want to do is we want to code United States citizen as 1, and all three of these other categories as 0. So let's move this window aside, because I want to keep this up as a comparison. You could always run it again. You can also jot down the numbers. However, I'm just going to keep it open. I'm going to go over here and we're going to go to the transform. Now within transform, we're going to go down to recode into different variable. Now there are two of these. They do very similar things in that they take one variable and they change it into a new variable of your desire by recoding the values however you specify to the program. One of the dangers with using recode into same variable is they will actually overwrite your original data. As a general rule, I strongly encourage people not to do this unless there's some specific reason. I generally prefer to use recode into a different variable, because what this will do is it'll make an entirely new variable. It'll fill in here as variable 20. And at that point, if we made a mistake, we can go back to the original data. However, if you recode it into the same variable, it'll overwrite that data, and that's a problem. Now, before you do any of these types of things, you want to make sure you've saved your data set into a different form. So in this case, the Federal Sentencing Dataset 2006, I've added cleaning at the end, telling myself I've saved it as a different data set just in case I make any mistakes, because we're going to be manipulating the original values actually over here in the data view. We're going to be changing some of these when creating new variables. So once again, let's go into transform. We'll go down to recode into different variables, and we'll click on that option. We get a dialog box that we should be familiar with at this point in time. All our variables are listed over here on the left-hand side. Right here we have a box that says input variable and output variable. The output variable is over here. This is going to be the new variable that we're going to create. So we are using this variable citizen. Once again, that's what we're recoding. And we're just going to pull it over into the center. And the computer program's telling us now it's going to transform citizen into some new variable. So what we want to do is we want to have a name for this new variable, and we can call it whatever we want. In this case, let's go perhaps not all that creative, but we know what it is, and let's call it citizen2. Once again, nothing wild and creative, but it allows us to know exactly what it is. Now, we can put a label in now if we want. We could do it later. At this point in time, we could just say recode. So in this case, I put in recode of citizen into citizen2. This just tells me where the data originally came from. If I click change, notice how it puts citizen2 in here. So this is telling me it's going to take the data from citizen, make a new variable called citizen2, and it's going to basically transform the data based on what I tell it to do. Now, if I go down here to this old and new values and click on it, this is where we can tell it how to deal with old values and how to change those values into the new values for this new variable. Now, remember before we had values 1, 2, 3, and 4, and then missing values as well. And once again, this is why I left this box open, because we can look over here to what this original data says. So 1, 2, 3, 4, and then these are all missing within the data. So there are basically 5 things we need to make sure we're taking care of. So once again, go back into the old and new values, and the reason I had to click out of this is sometimes when you have a secondary dialog box, you can't bring up any other windows or anything of that nature. You actually have to close out of them to go back into it. So opening the old and new values up again, we want to recode the old values into these new values. So we had United States citizen, which was value 1, and we want to go over here and we want to recode that. We're telling the computer basically all the ones in the old variable, we want you to make it whatever value specified in the new variable. In this case, we want to make it 1. So we're just taking those US citizens and converting them into US citizens. In this situation, so we have that taken care of, and then we have scores 2, 3, and 4. Now remember, we wanted to convert those into 0. Now we could put 2 and go 0 and add it in. However, there's a faster way to do this, so I'm going to remove this. We can actually specify a particular range of values that we want to enter in. So we could enter 2 through 4, so this accounts for 2, 3, and 4 within that variable. The old variable, the citizen, and in the new variable, citizen2, we want it to be a 0, and we add that in. So once again, this is going to start developing a list of all the values that it's going to, or all the computations, the changes that the computer's going to make from our old variable into our new variable. So 1's become 1, 2 through 4 become 0, and remember, we still have those missing values. So, to be safe in this situation, we could go all other values. This would include missing, specified missing, anything like that. We want to copy or change those into missing values. So this would be if there were any extraneous values. So for example, let's say there were some data entry errors. Someone accidentally hit 5 when they were meaning to enter 4 or something of that nature. Someone hit 1, 2, so we had some 12s in there, meaning that 1, and maybe they just didn't tab over fast enough when they were actually entering data, so they entered 2 for the next one. Anything like that will be caught up with the all other values coded as system missing. So what we can do is we can account for that in there. Once we look through here and know everything's good, 1's to 1, 2, 3, and 4, all over to 0s, and anything else that's left in the data is coded as system missing. We can go continue and go back to this screen. Now once again, as long as everything is good, we feel comfortable, all the information's entered, so we have citizen become a citizen2. This is the label we're going to give it. These are all the value changes we have. We can click OK. And when we do, that data is going to change, and we get a brand new variable right here called citizen2. Now, it's extremely important that we've made changes. We want to make sure we verify that the citizen2 variable, and once again, we go to the data view, we can view it, our beautiful brand new variable. If we slide all the way down, we can see it's in there. So now we want to examine, did the computer actually do the computations that we wanted it to do? So we need to check this. We need to go into Analyze, Descriptives, and we need to run frequencies for our brand new variable. So we don't need citizen anymore. We already ran it, so we can move that out, but we can go down to citizen2, bring it in, and run it with just the frequency tables. That's all we need. So what we want to do here is we want to compare the values of the old variable to the new variable. Now in the old data, we had United States citizens, which were 43,696 individuals, and here we have one as 43,696 individuals. Sorry, swap the 3 and the 4. Once again, this looks like it's done exactly what it should do. We also see that resident alien, illegal alien, and the kind of unknowns alien status are all coded in here, about 2,000. 24,500, 25,000, something in that ballpark, and look, 25,000. So if you want to be really detailed here, you could add up all of these, grab a quick calculator, do the calculations to make sure exactly this number adds up with this brand new 0, because remember, we took all of these, 2, 3, and 4, and coded them into 0, so they should show up right about there. Just eyeballing this, it seems like it's fairly close. Additionally, the United States citizen is identical and the missing cases are the same. So we should feel fairly comfortable. However, if you notice down here in this new recode of citizen2, we have 0 and 1 instead of the actual labels. Now remember, we can change this. We talked about this in a previous video. We can go down to the variable citizen2 that we just created. Remember, it put in this label because we inserted it in the dialog, but it didn't give us the option to enter values. And we can do that here by clicking a little blue box right there and entering the values. So remember, 1 is a United States citizen, and we can click add. So now it will tell the computer that 1 is a US citizen and 0 as other citizen status. Just putting something in there so we know. When we click OK, and we can double check to make sure those took, we can just basically run our frequency box again, and lo and behold, the labels pop out. So they're properly labeled, we know what they are, and we feel good about this. So there's a variety of different types of recodes that you could do. In this case, we simply took a bunch of values and combine them in. We could do some other fancier stuff as well. So I'm going to close this dialog box. We're done with this recode. We feel comfortable. Let's examine something else. Let's examine this number of months in prison. We used this in one of the previous, the descriptives video. But let's just take a very fast look at it. We can bring up frequencies. I'm going to reset this because we're done using that variable. Months P for the months in prison the individuals were sentenced to. We're just wanting the frequency table, so I want to see what this data looks like. And lo and behold, we have about 13,604 cases where someone was sentenced to no time in prison. So these individuals were put onto some type of probation by the judge, deferred sentences, something of that nature. Let's say we really wanted to know about these particular individuals. We want to identify them with a new variable, whether someone received this kind of probation deferred sentence or not. Notice we have all these other values accumulating up to some very extreme sentences, 3,700 months, with additionally 528 cases that are missing. Let's do this. Let's make a new variable where 1 is they receive probation and 0 is they receive something else. So either the value is a very high sentence, a medium sentence, or a low sentence. They receive some number of months. So let's go ahead. We'll leave this open for the moment being because we'll want to compare it to it. And let's recode months into something else. So once again, let's go to recode into different variables. We still have our citizen recode. So let's go ahead and reset that. Bring up months in prison, and let's call this probation. So I'm just going to call it, did the citizen receive probation? Something I oftentimes do is in parentheses, I will, if I can't tell very easily, I will place in the variable that I recoded from, just so I could backtrack if needed. Ooh, I already have a variable called probation in here, so let's call this probation 2 and change. So now months P will be converted into probation 2 depending on how we define it. We cleared everything out, so everything is gone here. Once again, remember everyone who theoretically received probation or suspended sentences, it was a 0 because this is the number of months we're calculating, or we had previously. Now we're just converting it into a value label for all intents and purposes. So 0 into 1, we can add that in, and we can basically take at this point the range. So we add 1 months going all the way up through, and click out of here to double check exactly how many months, 3,781 months. So we can turn around and put in a range of 1 through 3,780. I'm just going to go 2 to make sure we overshoot that by 1, and we could change those to 0. Additionally, you could have done a range lowest through or highest through. So we could have done 1 through the highest value, and let's actually go ahead and do that. Let's remove this. Let's try this range through the highest. We'll go 1 through the highest and say those are all zeros. And notice also, because we didn't save last time, we lost our actual probation value. So once again, people who had 0 months, we're going to turn them into a 1, indicating they received probation. Once again, all other values, just in case we missed anything, toss them into system missing, add that in, and click continue. So everything should be good. We're going to convert months into probation 2. We should feel good about this, so we click OK. This, once again, is just the background syntax code as the computer is generating basically what the commands would be typed out. And we can enter this information in. Now, once again, let's go ahead and define these first. Remember the categories. So 1 was if the person received probation. And 0 was if the person received some type of sentence. And remember, 0 and 1 is just arbitrarily assigned. We could have flipped them around. We could have said 1 is for someone who received a prison sentence, 0 is probation. I'm just setting it up this particular way because the interest variable there is probation, and that's why I defined it as the 1, but you could absolutely define it the other way. So we once again go into descriptives, move months in prison back over, bring our probation to variable over, and run it. And this would allow us again to double check and make sure everything's good. So someone who received probation, we have 13,604. Slide back up here and double check. And in fact, 13,604 would be embarrassing if it didn't code that way. And we can look at all the additional scores. You could do the math, but it seems like everything has gone out. About 528 cases, 528 cases. This seems about right. And about 58,000 additional cases. So we should feel good. We should feel comfortable that these variables have been coded over. Let me show you one more quick example. Another way you could use this as well. We're going to take something such as education. And this is kind of some of the Likert stuff I was talking about earlier. If we want to take education, which is coded in this data set, as less than high school graduate, some college, or college graduate. If we wanted to combine this, so we just had high school education, which was less than high school and high school, versus college and some college, college graduate and some college, just a high school versus college, a quick dirty assessment that's just two values, we can go ahead and do that. So once again, as we've been doing with everything else, we would go into recode, we would reset. So we don't want any of that original data there as a previous recode, and we don't need it. So we can pull over education. We can call it education 2, unless I already have education 2 in there. And we can just call it high school versus college. And once again, I have a habit of just putting in what the old variable was in parentheses there, just so I know. Again, that's just something I do. It's not something you have to necessarily. So remember, the old values were 1 and 2. And we're going to code that into, this time let's just code it into 1. And we can go 3 and 4. And let's just code it into 2. Now, again, my preference is always to code 0, 1, but just demonstrating you could code that the numbers are fairly arbitrary. And run it. Now the problem here is we didn't run any descriptive calculations beforehand. So in order to verify the information, make sure we did successfully do a good recode, we will want to go in here and not only run the new variable, but also the old variable, because we want to make sure we're comparing them. We want to make sure that the coding was done correctly. Once again, we just need the frequency tables. We're just looking at raw counts, and it looks ballpark like we are in kind of that range. Now once again, we did not define these beforehand. Actually, we did not. My mistake. So once again, 1 was high school, and 2 was college. So if we do this, I'm going to close this out real quick like that didn't happen, and run this one more time. Just going to leave that there. We're just rerunning it. We should get the labels to pop up correctly. Yes, we do. And we can see the high school individuals should be coded together. 32,000, 19,000. Looks about right. Yep, looks about right there. And sub-college and college should come out 7, 8, 9, so about 13, almost 14,000. So just eyeballing is, once again, if you really want to be sure, grab a calculator to double check. But just eyeballing it, it looks like these codes are correct. So once again, about 13 going to 14,000 here, and about 52,000 here. Once again, the system missing are still there. Now notice on the last one we didn't recode all else into system missing. Once again, that's just a protection I typically take. However, those codes should have still gone over as being blank, because the computer, when generating them, would have said there was nothing specified. Let's just leave them blank. And in those situations, they carry over. So another function I want to, or another tool at your disposal that I want to talk about is this compute function. Essentially what this allows you to do is do mathematical calculations with your values. So for example, we have two values in here, and once again, keep in mind, theoretically with the sentencing data set, I'm just doing this for as kind of exploratory purposes. This is no theoretical direction. This isn't something you necessarily want to do. But we're going to examine two variables here, the subtotal of criminal history points applied, as well as the final offense level. So let's say you wanted to do calculations, and you wanted to make this a new measure that combined the final offense level with criminal history. So how severe was the crime the individual committed, combined with what is their criminal history score during sentencing. So you want to put both of these into one variable. There's a variety of statistical reasons why you might want to do this, which we can discuss at a later time or date. However, how do you combine these two things? It would be kind of insane by just transforming them, because you would have to specify a whole bunch of values. Let's take a quick look at them and see what they actually look like. So I'm going to reset everything out here, and let's move those in. So we have X full SOAR and criminal history. Run both of those and see these are values. So for the final offense level, within sentencing grids, there's a variety of different offense levels they can fall into, and the criminal history points that are applied towards sentencing. So 43 is a high score here, and 63 is a high score here. If we were calculating these or combining these through the categorical nature of the transformation function, it'd take a long time to do. So this the compute function allows us to deal with data in a mathematical sense. And let me show you what I mean by that. Let's go here into compute. So in order to access this menu, we'll go to transform. And instead of going down to recode, we're going to go to compute variable. It's going to actually allow us to do calculations between variables, and click OK, or click on the option. So it brings up like a thing that looks like a calculator. And this is beautiful because it allows us to add, subtract, multiply, divide different values, different variables with one another. This really opens up a huge level of possibility. So we want to make a new variable and make this new variable based on a variety of calculation that we can do. So in this situation, we have the target variable, which is this new variable we're going to create. And let's call this let's call it sentence index, just basically creating a value name for it, or a variable name for it when it pops up. Now we could also define the types or labels if we want to. I'm going to kind of leave that for now and really focus on the kind of core of this functionality, which is this numeric expression category. Now this allows us to do computation. So before we were talking about taking the X full SOAR, which is the final offense level, and we were talking about adding it with the criminal history points. So we can actually add it. So we bring over X full SOAR, we click the add button, and then we bring over the criminal history points. Remember, notice my cursor's right there. Criminal history points highlighted. I bring it over. Bam, there we go. So what this will do is it will add the score for X full SOAR plus the criminal history points, and that will equal this new, for each case in here, the sentence index value for each defendant. So it'll take the defendant's criminal history score plus their final offense level and add them together, and then for that defendant, that line, that row in the data, it will create that value as a new sentence index. So we do those calculations there, we click OK, and it will create a brand new variable called sentence index right there. Now once again, we haven't specified the label, so we would probably want to put that in if there are particular values. So there's going to be a lot of values. And we can go analyze frequencies, and let's take a look at what our new variable looks like. And here we go. So this is that new sentence index variable, and look, scores go all the way up to 95. And once again, that's because we took those two values and added them together. So for every defendant in here, those two scores were added. So this, once again, would combine those two. But let's say we turn around and had a theory that it's not an additive effect. You wouldn't add the severity plus the history. You would want to multiply them because there's a multiplicative effect in this situation. If that were the case, we could actually do this computation a different way. So let's go back in here, transform compute. And we have X full SOAR time criminal history points. Let's reset this and start from scratch. We will call it sentence index 2, being all creative like. And so in this situation, this time, let's take the criminal history points and the X full SOAR and let's multiply them together. So you take X full SOAR, bring it over, and actually multiply the little star by criminal history points. And we could run that. And this will create a new value, a new variable essentially, that will list out. And instead of adding these together, we'll multiply them. So the values are going to be much higher. Notice out here, yes, we get some values that are much higher. We would expect this because it's taking the sentence severity, multiplying by the criminal history points. So we have some extreme values out here. So you can basically create combinations from these. You could divide things. So for example, if you had a data set that was just a bunch of states or counties, kind of macro level data, and you had the population of each county, you could actually divide that by some other type of figure. So if you wanted to take something like number of crimes and divide it by your population, you could actually get a crime rate. So the number of crimes divided by the population, crimes per individual citizen. You can do a variety of different types of things. You can combine several variables. You don't just have to do two. You can combine several variables. So, for example, if we wanted to do index 3, we could find all sorts of variables if we wanted to add them together. Toss things in here and add various variables together. Now, once again, you have to you need to have some type of reason or theory behind this. Some individuals like to add things such as Likert scales, those strongly agree, strongly disagree types of scales together. You do need to think about how those are scored, essentially, what the values look like. There are some kind of theoretical things you need to keep in mind with that. But this does give you the capability to do that. Just make sure your methodology is sound, make sure your reasoning is sound, and that you're comfortable with the output that you're putting out. Additionally, within any methods you give or any kind of reports, make sure you very in detail describe exactly what you are doing to your reader, and that way you're open and transparent about what your methods are, what exactly was done, and if something was done inappropriately, people can comment and you can always make modifications and changes to bring it in line with good social science.